Okay, good day, everyone. Thank you for tuning in again to one of our lectures. Welcome back after the holidays, and we're starting today with our next session. We currently at the project organization. We've already covered units 1, 2, and 3, and we're starting now with unit 4. So just for the distance learning students, please note that this calendar is for the residential students, so please refer to your study guides for your timeline, although this is what we will be covering in the next few weeks. Okay, so please note this: the residential students are writing their test now in the beginning of May, so we've got quite a bit of work to cover. Okay, starting looking at unit 4. In this session, this recording, we're only going to look at chapter 7, which is managing risks. Please note that this unit is all about managing risk, planning the process, and then programming techniques. We're going to look at what type of programming techniques there are. You will must be able to identify risks on a construction project, identify mitigation risks, and then draft a risk management plan. So the main focus of all these items is to look at managing risks. Okay, so let's start. Managing risks, you will find it on page 116 of your textbooks. Cook and Williams starts with just identifying general items in construction risks, and construction risks. The construction industry is a very risky business. Usually there's poor record of cost and time certainty. Adversarial attitudes and disputes may arise often, and there's low margins and profits and profit risks that we are exposed to. There's lots of health and safety risks. There's pressure to produce high return, and then there's also pressure on construction teams to perform. And then there's always pressure on health and safety. So not only are there health and safety risks, there are also pressure from the other side. You will see later on health and safety that the risks are from both sides within the construction process and from constitutional level as well. Okay, Smith categorizes risks into the following three risks. It's known risks, risks that are an everyday feature of construction. Then there is the known unknowns, risks which can be predicted or foreseen. And then there are the unknown risks, the risks due to events whose cause and effect cannot be predicted. So those are the three risks that he identifies. Then continuing, you will see there's a report, a Turnbull report. That's not that important. In that report, there's a few significant risks which is listed, which is market risk, credit, liquidity, technology, legal, health and safety, and environment, reputation, and business priority. That's not too important to me now because that you already did in your previous years of study. But starting with project risks, not all risks can be removed from a project, that you will know. And then the aim of risk management is to ensure that such risks are managed effectively by the party best suited to do so. So for instance, if it is a like for instance your people on the ground, if like for instance the site maintenance, or if a site is a dirty site, it can cause a lot of accidents, and it's more prone to be accident prone. So your housekeeping personnel on site is very key to actually mitigating that type of risks. Okay, then risk can either be reduced, retained, or removed, and that's very important for me. So please note that. So for instance, this little cartoon of working on a rooftop, here's the conventional method and what can happen. You can, especially on a steep roof, you can have accident happen very quickly, and simply using a harness, you can improve the safety of the personnel on site considerably. Obviously, roofs installer specialists will be more equipped to have these type of material safety harnesses and PPE available. Okay, then this is very important for me, figure 7. This here you can see the different size of pressure, managing risk process, risk assessment from the one side, and then risk management from the other side. So it's very important to identify your risk, assess the probability, and prioritize your risks. Then only once you've identified it can you control your risks on site. So you can either reduce, retain, or remove, as I said in the previous slide. By reducing it, you can eliminate or substitute. You can reduce your chances of it happening, and then you can reduce the effect of it. You can retain it, like self-finance. This is now, for instance, for material risks or importation risks, cost fluctuations, etc. And then you've got contractual insurance to remove some of the risks and move it to someone else. And then you have residual risks, the risks that that I'll explain a little bit later on. But all of this comes together from risk management. Okay. Then the next item is your risk register, and this is just a typical example. We'll embroider on this a little bit later, but in all essence, you basically have an item, a description. You identify it as a high, medium, low risk. What's the cost impact, time impact, or other impact that it may have? How will you mitigate it? And then if there's residual risk, and then you've got an action to actually address that risk. So it's very plain simple. The biggest issue usually is to actually just sit down and identify all your risks, because as you will see later on, if you don't identify risk, you cannot do anything about the risk. Okay, then the CIDB defines risk register keeping as a formal record of risk identification, assessment, and control actions, which can be divided into our generic risks. The generic risks represent risks which are irrespective of project type or nature. This is the stuff that you will always have on a construction site. For instance, the risk of oversupply of material, and or if you overmeasured, or if you undermeasured and you have to ask for more material, or you have to send back material at a certain cost. So that's for the contractor, an example of a generic cost. Specific risks which are particular to the project in hand, and this is now, for instance, if you've got a confined space within a built-up area, for instance, you have to have shoring to protect the buildings next to it. So that's a specific risk for a specific site. And then you have residual risks, the one that I spoke of in the previous slides, which is the remaining risks despite the control measures. Those risks that you can't do anything about, which you can or you can do fairly little about, and just mitigating that. For instance, putting on PPE, which is your last resort for reducing risks. Okay, then going to the risk assessments. There's certain items that you need to look at. Losses due to risk should be prevented and include the following: accidents to workers, accidents to the general public, loss of skill and experience, damage to property, loss of time and production, loss of money and contracts, and loss of your reputation, and thus future business. You will find this on page 119, and it's embroidered in there a little bit. You will see table 7. Table 7 is very important for examples and for discussion purposes, so please note that. But the basic steps that's highlighted in figure 7 is, firstly, you need to identify your risk, and then you identify who or what might be harmed, and then you evaluate the risk arising from hazards, and then you determine the control measures that is required. Then you evaluate the remaining risks, and then you record your findings, you make a contingency plan, and then you constantly review and revise. These risks you will see and these risk assessments are cardinal to health and safety. Usually your health and safety consultants start with baseline risk assessment, and for each month they do an audit and they identify risks. But that doesn't mean that we as construction managers should not look at risks. For instance, some companies have ISO regulations which require you to look at your risks at least every 2 weeks, and not monthly risks, but that is dependent on each company. Okay, then I just included the risk matrix. You will see table 7.2. This is a very simple one. I included a more elaborate one with just more stages, but it does exactly the same. It's basically, whenever you have a risk, you identify your risk, and then you identify the severity of the risk and the likelihood of it actually happen. So very easily, for instance, you can identify open trenches perhaps as a risk. So you have you look at the severity, if it's very deep open risk trenches that you have, and if someone does fall into it, they can get the injury will be quite bad. You can actually the severity will have a high rating, and the likelihood that it might happen might be between a low, medium, or high. So for instance, if it's in a built-up area, the chances of it actually happening is 2. So instead of just putting up danger tapes, you may put up barricades. So in this instance, your risk will be highlighted as a high. It might even be a free, which will also highlight it as a high, but because it is quite a severe incident, even if the likelihood of it is quite low, you will still sit with a medium high risk. So that's the thought process that one goes through in identifying the risk priorities on site. Okay, then we get to client risk against the contract risk. Okay, figure 7.3 is just a very nice comparison for your procurement risks. So you either have traditional lump sum risks, which the finance and the design is all on the client, and then the contractor is responsible for the construction. Then you have client-led design build. Now it moves slightly towards the contractor because he gets involved in the construction bit a little bit earlier on, and actually has a bit of input into the design process. And then you have a contractor-led design and build. So you have the client is still responsible for the finance, and then the appointment of the contractor, who actually appoints the rest of the project team. So you can see how the risk is shifted to the contractor. And then you have management contracting, which is now shifted to more towards the client, because the client is now taking the responsibility of the project management side, and thus the contractor is a little bit less responsible for the construction. Then you have construction management, where the client actually is very involved in the construction process, where most of the risk actually moves towards the client. And then the contractor financed one, just going back to the construction management, this is like developers or so that will fall underneath this type of arrangement. And then you have contractor finance, where the contractor actually acts as the developer, or the consultant actually does a development and takes most of the risk on himself. This is what usually happens when work is maybe low and contractors try and generate their own work. Okay, then briefly looking at client risks. Clients have very specific risks: failure to keep within the cost estimate, ditto for the completion date, and ditto to achieve the desired quality and function. You will see this on page 121. Okay, then the client is at risk on the project level. You can read through the items. It's embroidered on page 122 to 123, but basically you have feasibility risks, return on investments. You have design risks, like for instance your functionality, structural, etc. Then your funding risk, negative cash flows of contractors does influence the client. Then you have tender risk, depending on availability of information. Then obviously you have time risk, and then you have commercial risk as well. Okay, looking at the contractor's risk, the contractor commits to the price of the program and have the following risks: the tender risk, previous experience, financial stability, client, market conditions, inflation, and ground conditions, etc. So whenever you do conduct a tender, if you make a mistake in the tender, it's always a risk to the contractor, depending on the amount of information supplied to him. Okay, the quality of risk, tested by both parties. Okay. And then you have subcontractor risks, guys not producing. And then obviously you have design risks. If the designers actually looked at everything, you may argue, but that goes back to the designers, but it still stays a risk, even because if there was a design mistake, it's still the contractor that might be influenced. For instance, now the work has to stop while a design is fixed. So that's where your time is, RFIs and information requests is very important. Then obviously you have your program risk, whether you can actually do this work within the time, and penalties that can be ensued. Your method risks, this is actually if some of the items are buildable. Nowadays there's quite a lot of funky designs from the architects, and it does pose some risks to the contractor whether they can actually do that work for that amount. And then obviously you have health and safety risks, and then documentation, unrealistic terms set by the contractor. by the client and the consultants. For instance, timelines is usually one. Clients usually push the envelope, and you have to be very clear about that risk and trying to mitigate that risk. Okay, then we get to tender risk, and this is a specific risk that's highlighted in more depth. A risk assessment is done at a tender stage, which may or can have a possible saving on the tender figure. Over and under measurement work should be identified. Okay, you will see that on page 126. Buying muscle of suppliers and contractors are considered. Risk can be transferred to others. Subcontractors can be squeezed, or variations and claims can be anticipated. Commercial advantage is sourced. Buying in bulk, for instance. Loading and unloading the prices of inaccuracies. That's very important to note. Another example is loading your items that you will use first in your project to improve your cash flow. But we'll discuss that a little bit later during the course on what specific items one can do to actually be more competitive with your tenders. Okay, front-end loading, that was what I was talking about just now, where you actually load your items at the front of your project, for instance, your excavations, your concrete work, and so on. Obviously, you do that discreetly and all, but with the goal of you only make slight changes at the front, because the lower or the bigger your loading at the front, the higher your risk will be, because it might happen that when you remeasure your work on site, that your excavations might be much less than you anticipated, in which instance you will actually lose on your contract, because now your back-end items will not have the necessary rates or bulk of finance to actually carry you through the project. So please note that this is a very risky item, and the QSs usually pick it up when you do your leveling of your rates before you get appointed. And then obviously you get your back end loading, where you load some of your items at the back of your project. That might be, for instance, your finishes, etc. If you anticipate that that will actually assist you. If you can perhaps get certain items at a better cost, it might benefit you to actually load some of your items at the end of your project, or when you foresee that your cash flow might be low at the end of the project, you can actually load some of the items there. Okay, then looking at at a specific example of mitigating some of your risks to be actually more competitive in your tender. We've got an example. You can see this table also on page 126, but this is a basic design or basic project where you have your general preliminaries that you priced, you have your labor, your plant, materials, your subcontractor cost, you have your PC sums, your prime cost sums. Hopefully you guys know what that is. And then you have your provisional sums, and then you have your profit and overheads onto that. So here's your total cost to your projects, your net cost, and then you add your overheads and your profit, 126,000. So you get a final tender amount of 1.9 million rand for this project. But now if you go and look at it a little bit more in depth, you can actually see, okay, materials, I can maybe try and squeeze the suppliers and get off about 7.5% of material, so I've got a bit of a saving there. My subcontractors, I can negotiate, for instance, that they take some of the risk for their work insurances, etc., perhaps, or they need to buy the material, so you can squeeze them and get their cost lower to 82,000. You might also find at tender stage the guys will price, your subcontractors might price a little bit higher, because they don't know the exact scope, but you anticipate as the scope gets clearer that they might give you a discount on the appointment, and you can actually negotiate a lower term with them. So you anticipate that, okay, I can maybe have a saving of 10% on this. Your prime cost items, you anticipate that you might have a 2.5% saving there, and your provisional sums, your markup on those items might also be lower. So you think, okay, I might give a discount of about 8% on that. Just look at your the notes that they also include in this table for your provisional sums and your preliminaries. Assuming rates for the work will include 7% markup, and allowing a commercial opportunity of say 5% on the materials and subcontractors. So yeah, it's just basically playing with the figures and mitigating your risks. And then finally, your preliminaries, and this is a very important place where you will always try and get away with as much as possible evaluating your risks. But a very simplified thing that they considered here is assuming 4-week reduction on the 20-week contract period, and that all preliminary costs are time related. Okay, so basically they said, okay, this is a project earmarked to be 20 weeks, but we're going to do it in 16 weeks. So we're going to get off-site earlier, and this is where contractors usually make the best or the highest amount of profit, is to actually get off-site as quickly as possible. So please remember that. So this is where you actually can have the biggest competitive edge on other contractors. So all these possible savings are added, and you subtract that from your contract amount. So effectively you are 145,000 Rand more competitive towards your original estimate that you had, and that is basically how you mitigate your risks. Okay, very simplified, but I think it does explain how you can mitigate your risk and or evaluate your risk to get a competitive edge during your tender stage, and the things that you need to consider. Okay, then health and safety, the last 2 points of the chapter. I'm not going to focus too much on. Health and safety risk is addressed in more detail in chapter 12, so we're going to look at it later on during the course. Then the fire risk, I just wanted to highlight the following. A construction site does have is more prone to fire risk than anything else. So because you have hot work such as welding, blow lamps, cutting and grinding, etc. You have heating appliances on site, especially gas bottles and welfare facilities. Litter, especially in restrooms and drying areas, might pose a risk, obviously. And then arson, some disgruntled employee that might feel he wants to retaliate and set the building alight or something like that. Then smoking on site is a very big problem, and then burning of waste on site, especially in winter time here in South Africa. People trying to get warm, that's also something that needs to be considered. And then obviously stored materials including adhesives and solvents is very important. Okay, thank you. That's chapter 7 for you. I will also let you guys know about the informal assessments. For the distance students, the informal assessments will start next week Friday online. So please start going through your notes again, and also please read for your chapter 7 for me. And thank you. Next week I'll post the recording with the residential class, which will be on chapters 8 and 9. Thank you. Bye.